Hello student, today's we're gonna learn equation reducible to exact differential equation by integrating factor. In the last lecture, we have seen that exact differential equation and the solution of exact differential equation. Okay, now let us see non-exact differential equation. When we say that a differential equation is non-exact, okay, the differential equation the differential equation m dx plus n dy equals to 0 is said to be non-exact if dou m by dou y not equals to dou n by dou x, right? As we seen in the differential equation, if dou m by dou y is equals to dou n by dou x is exact, right? When we say that the differential equation is exact. But in this case, suppose this is not equal, then we say that a given differential equation is non-exact, right? Okay. Now, integrating factor. What is the integrating factor? So, the given differential equation m dx plus n dy is equals to 0 is non-exact, let us say. That means dou m by dou y is not equals to dou m by dou x. But we can convert it into the exact differential equation by multiplying some factor to this differential equation. That factor is called a integrating factor. Correct? So what is the integrating factor? The given differential equation is not exact, but it is converted into the exact differential equation by multiplying suitable factor. Such a factor is called the integrating factor. Correct? Okay. Now, note that integrating factor is not unique for the differential equation m dx plus n dy, right? That means for one differential equation, there may exist more than one integrating factor. So I hope you understood what is the integrating factor, right? Okay. Now, consider the differential equation y dx minus x dy equals to 0. It is not exact by default. So let us see this. Compare with this, compare with m dx plus n dy is equals to 0. So what is m here? M is this y. And what is n here? This x, right? Minus x. So what is dou n by dou y? It is 1. And what is dou n by dou x? It is minus 1, right? So this implies dou n by dou y not equals to dou n by dou x. So this implies given differential equation is not exact. Correct? Not exact. Now, this is we have proved that it is not exact. But if you multiply by 1 by x square or 1 by xy or 1 by y square to given differential equation, then given differential equation is exists. Okay, let us consider factor which is equals to 1 upon x square. You called it as this is 1. Now multiply by 1 upon x square to equation number 1. So this implies 1 upon x square y dx minus x dy is equals to 1 upon x square into 0. So this implies y upon x square y upon x square dx minus 1 upon x dy is equals to 0. Right? Now, let us say this is our m dash and let us say this is our n dash. So, what is m dash here? It is y upon x square. And what is n dash here? minus 1 upon x. Now, let us take m dash का partial derivative with respect to y. So, dou m dash upon dou m dou y. So, it is y का derivative is 1. So, it is 1 upon x square, and dou n dash by dou x is minus 1 upon x square into minus 1. So it is 1 upon x square. So this implies dou m dash by dou y is equals to dou n dash by dou x. So this implies given differential equation, which differential equation? Y upon x square dx minus 1 upon x dy is equals to 0 is exact. Okay? Is exact. Correct? So this is given differential equation is exact. Right? Now, original we have this equation y dx minus x dy. This is not the exact one, na? But if you multiply 1 upon x square to this equation, then we got this equation y by x square dx minus 1 upon x dy equals to 0, and we got this is the exact one, right? That means suppose we have non-exact differential equation, but we can convert it into the exact one by multiplying factor, and that factor is called the integrating factor. So in this case, the integrating factor is with integrating factor is equals to 1 upon x squared. Now, consider factor is equals to 1 upon y squared, right? Okay. Multiply 1 upon y square to equation number 1, right? So 1 upon y square into, what is equation number 1? It is y dx minus x dy. Y dx minus x dy is equals to 1 upon y square into 0, right? So this is equals to 1 upon y dx minus x upon y square dy is equals to c, right? So let us consider this m double dash, and this is n double dash. Huh? This is not the double derivative. Huh? This is just a notation of the function, because we have already taken m and m dash. So here we take the m double dash and n double dash, right? So m double dash is equals to 1 upon y, and n double dash is equals to minus x upon y square. Now we need the dou m double dash upon dou y, and it is exactly minus 1 upon y square, and dou n double dash by dou x, it is minus 1 upon y square. So this implies dou m double dash by dou y is equals to dou n double dash by dou x. So this implies given differential equation, which is the differential equation here? This one, right? 1 upon y dx minus x y square dy is equals to, this is 0, sorry, this is equals to 0 is exact, right? Now see here, the equation number 1 is not exact, but if you multiply a factor 1 upon y square to the equation number 1, then we got this differential equation is exact one. So that such a factor is called the integrating factor, right? Now, first factor we found that it is 1 upon x square. Second factor we got 1 upon y square, correct? So here we have proved that for a particular differential equation, we may have more than one integrating factor. So here for equation 1, integrating factors are 1 upon x square, 1 upon y square, similarly 1 upon xy. Okay, we can find any other, uh, means we can find another integrating factor also here, right? Okay, now, so I hope you understood what is the integrating factor. So integrating factor is a factor when we multiply the given differential equation, that given differential equation converted into the exact differential equation. After getting converted into the exact one, we can define the solution for the exact differential equation, right? Okay. Now, so now the rules to obtain integrating factor for the differential equation m dx plus n dy is equals to 0. Right. So there are total 4 rules. Now in this lecture, we see only the one rule. What is that? If dou m by dou y minus dou n by dou x upon n is function of x only, say f of x, then integrating factor is equals to e raised to integration f of x dx, right? So integrating factor in this case, e raised to integration f of x dx, right? Okay. So let us see example. Right. Now, first step, always compare m with m dx plus n dy. So compare with m dx plus n dy is equals to 0, right? So m is equals to x square plus y square plus 2x and n is equals to 2y only, correct? So check this is exact or not. So dou m by dou y is only 2y, correct? Because this is free from y, this is free from y, so it is 0, and y square ka derivative with respect to y is 2. And dou n by dou x is directly 0 because it is free from x. So here dou m by dou y is not equals to dou n by dou x. Correct. So this implies given differential equation is not exact. Given differential equation is not exact. But we can convert it into the exact one by multiplying the integrating factor. And what is the rule to find the integrating factor? So rule number 1 is if dou m by dou y minus dou n by dou x upon n is function of x only, then we say that integrating factor is e raised to integration f of x dx. Okay. Now dou m by dou y minus dou n by dou x upon n. What is dou m by dou y? It is 2y minus 0 upon what is n here? N is 2y. This is correct. This is 2y. So this implies 2y upon 2y is equals to 1, right? So can I write it as 1 as x raised to 0? So it is function of x only, na? Function of x only. So we can write integrating factor as e raised to integration f of x dx. Correct. Now e raised to integration. Now what is f of x here? F of x is 1 dx. So we can write it as e raised to x only. So here integrating factor is equals to e raised to x. Okay. Now multiply integrating factor is equals to e raised to x to equation. Let us call this is as equation number 1. Equation 1. Okay. So e raised to x bracket x square plus y square plus 2x dx plus 2y dy is equals to e raised to x into 0. 2y dy is equals to 0. Right? So this implies e raised to x up into x square plus y square plus 2x dx plus 2y e raised to x dy is equals to 0. So called it as a equation number 2. Now equation number 2 is by default exact differential equation. There is no need to check the equation number 2 is exact or not. But here I am showing that this differential equation is exact. Now compare with m dash dx plus n dash dy is equals to 0. Here we have taken m dash and n dash because we have already taken m and n previously in the equation number 1. So this implies what is m dash here? It is e raised to x square plus y square plus 2x. And what is n dash here? It is 2y e raised to x. So dou m dash upon dou y. It is e raised to x into x square is 0, 2y and 2x is 0. So it is 2y e raised to x. Correct? Because e raised to x treated as a constant because we have to take the derivative with respect to y. So x square constant 0, y square 2y and 2x 0. Now dou n dash by dou x. So it is 2y into e raised to x. So this implies dou m dash by dou y is equals to dou n dash by dou x. So this implies equation number 2 is exact differential equation. Correct? Now, so equation number 2 is exact differential equation. So we can write the solution for the equation number 2, na? Right? Now, what is the solution to exact differential equation? What is that? We have a formula, right? M dx treating as a y constant plus integration terms free from x in n dy is equals to constant c. Right? So now remember here this m is exact differential equation kind. That means we have to consider the m dash and n dash, right? Okay. Now what is m dash here? What is m dash? It is e raised to x square plus y square plus 2x. e raised to x plus x square plus y square plus 2x dx. Now plus. Now terms free from x in n dash. Now look at the n dash, 2y e raised to x. So it contains x ka term. That means there is only term which is free from x is 0. So we have to consider it is 0 dy is equals to c. Right? So don't make a mistake here. Take the m and n here because solution of exact differential equation is m dash dx plus terms free from x in n dash dy. Right? Okay. So now we know that Leibniz rule. What is that Leibniz rule? Integration uv dx is uv1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus and so on. Dashes denote the derivatives, and suffixes denotes integration. Correct. Okay. Now here consider u is this and v is this. Okay. Now let us solve this. So this implies u as it is x square plus y square plus 2x. Now v1. What is v? E raised to x. What is v1? Integration of v. So integration of v is e raised to x only. Now minus u dash. That means derivative of u with respect to x. So it is 2x y square treated as a constant. And what is 2x? Ka derivative is 2 plus 2 v2. V2 means v1 ka integration. So it is e raised to x. Now plus u double dash, that means integration derivative of 2x plus 2. So derivative of 2x plus 2 is 2 only. And v3 integration of e raised to x is e raised to x minus 0 plus 0 and so on, plus integration of 0 is 0 is equals to c. Right? Now this 2 e raised to x, this is minus 2 e raised to x get cancelled. Right? Plus 2x e raised to x minus 2x e raised to x get cancelled. Right? So we are remaining with, so this 2x and this 2x get cancelled, this 2 and this 2 get cancelled. So we are remaining with x square plus y square e raised to x plus equals to c. So this implies x square plus y square e raised to x is equals to c is solution of equation number 2, and we can say that this is solution of equation 1 also. Right? Now here we have seen that given differential equation is not exact, but we have to convert it into the exact differential equation by multiplying some factor. After getting exact differential equation, we can write the solution for it, and this solution is solution of exact differential equation and solution of given problem also. Right? I hope you understood the first example. Now let us see the second example. Okay. Now, first read carefully, solve, x raised to 4 e raised to x minus 2m xy square dx plus 2m x square y dy is equals to 0, where m is a constant. Always, first of all, step number one is compare with m dx plus n dy is equals to 0. So this implies, what is m ka value? x4 e raised to x minus 2m xy square. And what is n here? 2m x square y, right? So this implies, what is dou m by dou y? X square e raised to x 0 because it is free from y, and it is 4m xy. And what is dou n by dou x? So it is 4m xy. So here dou m by dou y is not equals to dou n by dou x. So this implies, given differential equation, we mark it as a 1. Equation 1 is not exact. Correct. Now, we have to find the integrating factor to multiply the equation number 1 so that our differential equation will get converted into the exact one. Now, consider dou m by dou y minus dou n by dou x upon n is equals to, what is dou m by dou y? It is minus 4m xy minus, what is dou n by dou x? It is 4m xy upon, what is n here? N is 2m x square y, right? Okay, so it is minus 8m xy upon 2m x square y. Y get cancelled, m get cancelled, 2 4s are, and 1x get cancelled. So we are remaining with minus 4 upon x. So it is a function of x only, na? So if we got the function of x only, then integrating factor is equals to e raised to integration f of x dx. Correct? So e raised to integration minus 4 by x dx. Correct? So integration minus 4 1 by x dx. So we can write it as e raised to minus 4 log x to the base e. Right? Okay. Now we can take this minus 4 to the power, because we have a formula, right? A log b is same as log b raised to a. So we can take this e raised to log e x raised to minus 4, and this e, that means it is x raised to minus 4. So this implies integrating factor is 1 upon x raised to 4. Now multiply this to equation number 1, right? What is the equation number 1 here? X raised to 4 e raised to x raised to 4 e raised to x minus 2m xy square 2m xy square dx plus 2m x square y plus 2m x square y dy, right? We have to multiply by 1 upon x raised to 4 on the both side to the equation number 1, 1 upon x raised to 4 into 0. So we can write it as, if I multiply e raised to 1 upon x raised to 4 to the both term, so e raised to x minus 2m y square upon x cube dx plus 2m y upon x square dy is equals to 0. Okay, this is the equation number 2. So here equation 2 is exact differential equation. Okay, so there is no need to check the given differential equation is exact one, because it is by default exact, because we have multiplied by 1 upon x raised to 4 to get converted into the exact one. Now, and we know that, and we know that solution to exact differential equation, what is that? Integration m dx, y treated as a constant plus terms free from x in n dy is equals to c. Now, look at here. Equation number 2 is exact. That means we have to consider a m dash and n dash, where this is our m dash and this is our n dash, right? Because we have already considered m and n in the equation number 1, and which is not exact. And this is the solution of the exact differential equation. So for equation number 2 is exact differential equation. So for that, m dash is this and n dash is this. Okay. So integration y constant. What is m dash here? E raised to x minus 2m y square upon x cube dx plus terms free from x in n dash. Now look at the n dash. N dash, all the terms contain the x wala term. That means it is directly get 0. Dy is equals to c. Just we have to take the integration, keeping y as a constant. Now take the integration of this. What is the integration of e raised to x? E raised to x as it is minus 2m y square as it is. What is 1 upon x cube ka integration? It is x raised to minus 2 upon minus 2 is equals to c. Now this minus 2 and this minus 2 get cancelled. So e raised to x plus m y square upon x square is equals to c. So this implies we can multiply x square on the both sides. So it is x square e raised to x plus my square is equals to c x square. So this is solution to exact differential equation 2. So this implies this is solution of equation 1 also. So this is the solution of original differential equation. I hope you understood. Thank you.